Okay. Margin of error. So it says during data studies, observed averages from data samples are rarely exact for an entire population. The actual average for an entire population can usually be confidently predicted within a range from the observed sample average. We call this a margin of error. So you probably never really took a statistics course before, so that probably didn't mean a whole lot to you. But let me just tell you what like the margin error is for. So like let's say you were interested in finding the average height of a male in the United States. You wouldn't have time to go and measure every single male in the United States and then calculate the average height. You wouldn't be able to do that. Like every single guy in the entire United States, that's not going to happen. So what they do in statistics, they usually find a sample. They maybe measure like 1,000 men, find their average, and then they can confidently say that's a big sample is 1,000 people, and then they could say, okay, on average they're about 5'10", and maybe there's a margin of error of like an inch, so maybe 5'9" to 5'11" or something like that. Like that's what a margin error is for. It kind of gives you like an idea of, okay, this is our average of our sample, but the actual average might have a bigger sort of interval. So let me show you how we apply this. Okay, so it says in a study of 100 adults over the age of 65, it was found that 45% of them have a social media account with a margin of error of 4%. So they just surveyed 100 adults. And it was found that 45% have a social media account with a margin of error of 4%. So it says, between what two percentages could one confidently say adults over the age of 65 have a social media account? So if the average I got was 45 and it's got a margin of error of plus or minus 4, then we would say 41% and 49%. So what I did was, since the margin of error was 4%, I went 45 minus 4 to find the lower end of the percentage. And then I did 45 plus 4 to get 49% to find the upper range of the percentage. Okay, so that's plus or minus 4. We dealt with plus or minus before in the quadratics unit, right? So I did 45 plus or minus 4. 45 plus 4, 49. 49 minus 4, 41. So I can confidently say between 41 and 49% of adults over the age of 65 have a social media account. That's what I'm saying here. So this is where we can use this then. So it says in a population of 16,000 adults over the age of 65, between how many of them could one estimate to have a social media account? So what I would do, I would take that 16,000 adults, and then for on the lower end, we'd say 41% of them have a social media account. So on the lower end, I would multiply this by 41%. Remember, we got to make it a decimal, so move the decimal over twice. So it would be 0.41. So out of 16,000 adults, we can say possibly 6,560 have social media account, and then on the higher end, I'm going to multiply it by 0.49 for 49%. It'd be 7,840. So out of those 16,000 adults, I could say between 6,560 and 7,840 have social media accounts. That would be my prediction. So if I were to actually go out and survey 16,000 adults, I can confidently say that between 6,560 and 7,840 of them are going to have social media accounts. So that's like my estimate. Okay. Let me do another. I'll let you do number 2, actually. Let me do 3. And if you didn't understand it, watch me do 3 first. It says, based on a survey of 150 students at Jupiter High School, the average amount of money a student spends on school lunch is $3.20, with a margin of error of 15 cents. It says, give a range of value based on data for the actual mean amount of money students spend on school lunch. Okay, so they found the average was $3.20, but they calculated a margin of error about 15 cents. So the mean could be at lowest. If I do $3.20 minus 15 cents, that would be $3.05. And then on the higher end, if I did $3.20 plus 15 cents, that would be $3.35. So I would say between this. Because that was my margin of error, 15%, 15 cents. So I'd go 15 cents less than $3.20 and 15 cents more than $3.20. Now, B says if there are a total of 1,400 students at the high school who buy school lunch, give a range of values for the total amount of money spent on lunch by all the students. So if we have 1,400 students and they're all spending on average $3.05, so we're going to multiply. How much money would that be? 1,400 times 3.05. They would be spending $4,270. And then let's say it's on the high end for the actual mean of $3.35. They would be spending, if I multiply those, $4,690. So to answer the question, the range for the total amount of money spent on lunch by all the students would be between $4,270 and $4,690. So that's how much money in sales the school cafeteria we could estimate would make off of those 1,400 students. I'm going to do one more with the percentage because this one didn't have percentage, so you didn't have to do any conversions. Remember, on this one, we had to convert those percents to decimals. So let me do one more with percentage. So I'll do 4. It says a toy manufacturer has to provide refunds on one of their toys because of a defect. They determine that 1.7% of the toys have a defect with a margin of error of 0.1%. If they manufacture 200,000 toys, between what range of them will be defective? Okay. So first, let's create that margin of error with the percentage. So we're going to say between, so 1.7% is the defect based off of the sample, and then the margin of error is 0.1%. So it's going to be between 1.6% and 1.8%. So I just added 0.1% to both of these. So that's what my margin of error is showing us. Now there's 200,000 toys. So let's say on the lower end, just 1.6% of them are defective. So I would do 200,000 times, remember I got to change that 1.6% to a decimal. So I would move the decimal point over twice or divide it by 100. So this is going to be 0.016. I got 3,200. And then on the higher end, out of the 200,000 toys, and let's say 1.8% of them have a defect, convert that to a decimal, will be 0.018. That would be 3,600. So between what range of them will be defective? I would say between 3,200 and 3,600 toys will be defective. Okay. Sorry for the bad handwriting. I'll let you try the rest.